Alright, here we are, 4.2, multiplying monomials using laws of exponents. 4.2 from Dolciani Algebra 2 book. So just a reminder, remember that the exponent indicates the number of times the base is used as a factor. And over here I'm going to remind you that the b is the base, the e is the exponent, right? The b is the base, e is the exponent. Okay, you should remember that. So if we have something like x to the third times x to the fifth, this is x times x times x, because x to the third means you have 3 x's. X to the fifth means you have 5 x's. 1, 2, 3, 4, 5, right? So this means we have 3 factors. Okay, and we have x to the third. And when you have x to the fifth, then you have 5 factors, giving us a total of, we have 3 and we have 5, so 8 factors. Okay, so the answer to this means I have 1, 2, 3, 4, 5, 6, 7, 8 x's. So I have, my answer should be x to the 8th power. Okay, or I could use possibly a shortcut, right? Notice that 3 plus 5 is 8, meaning I have x to the 8th, right? So maybe this is a shortcut. X to the 3 plus 5, if I add those, then I get x to the 8th. Do you see how that's the same thing? X to the 8th, x to the 8th. Hence, we do have a shortcut or law of exponents. Our first law or rule. Okay, if we have a to the m times a to the n, this is a to the m plus n power. Okay, so let's use that knowledge to figure out the rest. But remember, that's only when we have the same base. So previously in this example, we had x's. Okay, for our rule, we have a's as our base. Okay, so if you have different bases, it's not going to work. So let's simplify this. Y to the fourth, y to the second. Right, this is y to the 4 plus 2. We do have the same base, so y to the 6th power. Okay, next one. We have numbers as well. When we have numbers, we'll group our numbers together, 4 times 5. And then we'll put our like bases, so n cubed and n squared, we'll put those together. So this is 20, n to the 3 plus 2, 5th power. Okay. Next one, same thing, we'll group our numbers together. -4 and times 7. Okay, then we have x squared times x. And then, so those are like bases. We have y to the 5th, y to the 4th. Okay, remember, -4 times positive 7, -28. X squared times x is x cubed. Okay, y to the 5th, y to the 4th, add those two together, we have y to the 9th. Final answer. Now for D, very similar. Okay, now we have fractions. Yes, many people are afraid of fractions, however, you can do this. 16 over 5 times 15 over 4. Okay, we'll group those two together. We'll group our x's together, x squared times x cubed. And we'll group our y's together, y times y squared. Okay, so if I can cancel anything in the bottom of any of these fractions, anything in the top, I'm going to cancel 5, that becomes 1, 15 becomes 3, 16 becomes 4, 4 becomes 1. So this ends up becoming 12 right here. Okay, we have x to the 2 plus 3, x to the 5th. Okay, this is an invisible 1. Often students forget that. Though if there's no exponent, that means 1 is the exponent. So this is y to the 3rd. So our final answer for this one, we have 12, x to the 5th, y to the 3rd power. All right, here, moving on to E. Okay, so a little more difficult. So we have to do this part of the addition sign and then the other part. So let's simplify first. So simplify this side, 2 times -6. Okay, then I have a times a to the 4th, and I have b squared times b squared. Okay, so this is -12 a to the 1 plus 4, which is 5, and b to the 4th. Okay, the other side, I have a lonely 2 by its lonely self. Okay, I have a squared times a cubed, and then I have a b times a b cubed. Okay, so there's a plus in the middle still. I have 2, a to the 5th, b to the 4th. Hey, look at that, a to the 5th, b to the 4th, a to the 5th, b to the 4th. So I can add these two together. Negative 12 plus 2, negative 10, a to the 5th, b to the 4th. Okay, what would be the degree of that monomial? Monomial one term, right? Degree would be 9. Remember for that from the last notes, 5 plus 4, so the degree of that monomial would be 9. Just a reminder. All right, so let's do the next one. X to the 5th to the 3rd. This means we have x to the 5th times x to the 5th times x to the 5th 3 times. And if we use that rule from the last time, this is x to the 5 plus 5 plus 5, which is x to the 15th. Okay, we could multiply it all out like before, but we'd have to write x 15 times, and I don't want to. Or possibly we could use a rule, right? 5 times 3 is 15, right? Do you see how we get that? So I could do x to the 5 and you multiply by 3. Notice this is kind of diagonal, right? These ones are straight across from each other, straight across, right? Straight across, straight across. So these ones, when they're straight across from each other, we add them. Okay, when they're going diagonally, like here, we multiply them. So x to the 15th. Okay, x to the 15th. So, hence, our rule or law, if we have a to the m to the n, this is a to the m n power. Multiply them together. So here we go with some more examples. Okay, m to the 3 to the 4. M to the 3 times 4, right, which is m to the 12th. Next one, x to the 2 to the 5. So, x to the 2 times 5, x to the 10th. Next, negative b to the 4th power to the 5th power. All right, little different, right? We have a bracket here. Anything negative to a even power is going to become positive, right? Negative b, negative b, negative b, negative b. 4 negatives make it positive. So we're actually going to have, this is going to become b to the 4th to the 5th power, which is b to the 20th. Multiply those exponents. Next, I think we have another one. Okay, so simplify. We have xy cubed. Okay, if we were to write this out, this would be xy times xy times xy, right? And then we can count up our x's. 1, 2, 3 x's. So I have x cubed, y cubed, right? 3 y's. Xy cubed, I could make this x cubed, y cubed by simply kind of distributing this exponent to the exponents of the other ones. Okay, so our rule for this one, if I do have ab to the m power, okay, this is going to become a to the m times b to the m. So both of them, you kind of distribute the exponents. So let's do a few real examples like you would have on your homework. Okay, 2y to the 4th. This is 2y times 2y times 2y times 2y, 4 times, right? Or I could just distribute my exponent, 2 to the 4th, y to the 4th, 2 to the 4th becomes 4 times 4, which is 16. So this is 16y to the 4th. Okay, next, negative 4mn to the 3rd. All right, so I'm going to put this negative 4 in a parentheses cubed, and then I have m cubed, n cubed. Negative 4 times negative 4 is positive 16 times negative 4 again gives us negative 64. Negative 64 m cubed, n cubed. So when you do this, you can't forget to distribute your exponent even to the number. So most of the times students forget to do it to the number. They'll do it to the variables because they remember. That's what we learned, right? Don't forget to do it to the number as well. Okay, so same thing goes here. 4 to the 4th power, a to the 3 times 4 power, b to the 2 times 4 power. Now remember, this looks diagonal, right? Diagonal. So make sure you multiply. 4 to the 4th gives us 4 times 4, 16, then 16 times 16, 256. A to the 12th, 3 times 4. B to the 2 times 4, which is 8. Okay, there's our answer for C. Okay, I do believe we have some more examples. All right, evaluate if x equals 2. So this is super important because often students mess up. So this is 3, and then it's only the x cubed. So 2 cubed. 2 cubed is 8, so 3 times 8, which is 24. Okay, so 24 is the answer to A. Next, we have the parentheses around the 3 and the x, meaning we have to do 3 times 2 first and then cube it. So this is 6 cubed. I don't know what that is at the moment, but 6 cubed, whatever it is. Okay, 3 cubed times x cubed, okay, meaning 2 cubed. So this is 27 times 8, which is 216. Okay. All right. Moving on. Continuing to simplify. All right, so put our numbers together. Negative 3 times 4. Okay, then we have x squared, y, oops, I'll put the x in there. X squared times x, and then we have y cubed times y squared. All right, so negative 12 x to the, now we add these together, right? 3 y to the 5th, add those together. When they're next to each other, you add them, right? Add them. There's an invisible one right there. Next one, st to the 4th cubed. This is going to be s cubed, t to the 4 times 3, right? S cubed, t to the 12th. Next one, negative x cubed squared, right? If I write this out, this is negative x cubed times negative x cubed. Negative and a negative make a positive, and I add those exponents. X to the 6th power, right? 6th power. No, I could multiply those exponents, but you need to remember that there's the negative in front ends up becoming a positive. All right, so more than 2 examples. U, okay, this u stays u times those multiply, right? U to the 6th times u to the 5th. Okay, so this is invisible 1. 1 plus 6 plus 5, right, gives us u to the 12th power. All right, next one. I have to distribute that 3 to all of these lovely, wonderful 4 terms. All right, so if I write it out, 3t squared times t cubed plus, I'm going to put it in parentheses now, 3t squared times negative 2t squared plus 3t squared times t, and then the other one I'll write out in a second. All right, so these two, add the exponents, 3t to the 5th plus 3 times negative 2, negative 6t, these are next to each other, to the 4th, right? And then plus 3t cubed. And then remember, I forgot the last one, so plus 3t squared times negative 4. Okay, we'll go down a little bit. So 3t to the 5th plus negative 6t to the 4th plus 3t cubed. And then this becomes minus 12t squared. And notice in order, 5, 4, 3, 2. Okay, all in order. All right, next and almost done. Okay, multiply these, right? A to the 2k times a to the, when we write that, you should put a 3 in front of the k. A to the 3k. These two are next to each other. So this is a to the 2k plus 3k, which is really a to the 5k. All right, next, x to the m minus n plus, because we add these two together, m plus n, and x to the m minus n plus n. So our n's are going to cancel for this one. N's cancel in this one. I'm going to have x to the 2m times x to the, just the m. Okay, multiply those together, and my final answer for this one, x to the 3m. Because you add them, they're next to each other. All right, enjoy.